Kia ora everyone, welcome to another video on Python Arcade. We're going to make a minigame from scratch today. We're getting to the point now where we've taken a look at enough different components and sprites and movement and things like that. We're actually able to start making some little playable, compelling games. Yeah, they're not that advanced yet, but they are playable. They can be quite fun as well. The thing we're really going to focus in on today is projectiles. How to get your character to shoot, how to get those bullets, those projectiles, to interact with other objects and other sprites, and how to do fun stuff like that. So here's what we're hoping to end up with: a little mini game. Bring my mouse over here and select it. You'll see my character is moving the mouse, moving with the mouse, but he's not moving up and down, just left and right. And if I click, boom, there we go, I've got a laser. And when that laser hits some coins disappear, and I get a point, and I've got a running score down the bottom. And you'll see as well that he is restricted to the edge of the screen as well, which is quite nice. Cool, that's what we're going for, and let's get cracking. So let me just close this and open up Visual Studio Code. That is the code for that project. I want the other one. Thank you, Visual Studio. Please hold caller. We want that one. Okay, we've rearranged our file. All our files there, all of our previous code is now tucked away nicely, so it's not looking too cluttered. I have a clean Python file here in our root of our directory. It could be down in a deeper file somewhere, but we're sticking with the root at the moment. Here's the important part. I have a folder called images, you'll see just above there. And inside that folder, I have my PNGs there. I've got my character, I've got my coin, and I've got my laser .png. And that, I think I just found that on Google. Maybe it's from the Kenny pack as well. I can't remember. I picked it up a while ago, and that's the one we're going to work with today. It will be on the GitHub, the repository for this project, if you want to find that one in particular. Or you can just find your own one and make it look good. All right. Okay, so we're going from scratch. What is the first thing that we need to do? Of course, we need to import Arcade. We'll do this as quick as possible. We're also going to need random today, so let's import that. We're going to need a few constants. So, of course, we need... constants are in all caps. Widths, I don't know, let's make it 800. Let's make height 800. And let's make the title is going to be a shooting game. Cool, nice. Previously when we've made sprites, we haven't actually used a constant to scale them before. We should do that, just in terms of like collecting all of our constants at the top of our game. It's really nice just to have them all nice and tidy up there. So let's make a few now. Then they'll be there, and we'll be able to tutu and play around with them later. So we've got a player, we've got a bullet, and we've got a coin. So let's say. And these are constants still, so all caps. Whoa, let's go with the caps lock key. Gosh, how often do you get to push that? Player scaling. Let's put the player down to 0.5. We know that these sprites are particularly big, so let's make them a little bit smaller. Coin scaling is going to be 0.3, and laser with a Z. Oh, goodness. Okay, let's pause for a moment. And we'll be back very soon. Hey, and we're back. Okay, change battery pack in the camera. Where were we up to? We were setting our laser scaling to I don't know, 0.5. It's probably not going to be right, but we can play around with it later. And we'll know where it is in our code because we've set the constants up the top. Okay. Oh, we're also going to need bullet speed for later on as well. Well, let's say laser speed. By the way, guys, this is very heavily borrowed from the Python Arcade tutorials on the website. If you want a reference, that's a really, really good place to go. They've got a little bit more information, probably a lot more information on this than I am providing, and a lot more information about actually how to use Arcade. This is under the book tutorial in, I think it's called 24.1, which is their laser game, using sprites to shoot. This is called. If you want a reference, go there. Okay, where are we up to? We are setting the laser speed to about 5 or so. And again, we can play with that later on. Okay, we need to make a game class. Oops, and caps lock is still on. So class is game. It's going to inherit from arcade.window. And we're going to define our initialize. Whoa! Undo, undo, undo. I think I've done that before. Define initialize, and of course we need self because this is a class. And the first thing we're going to do is call the superclass, which is arcade.window. And then we're going to call its init function, and it's going to be width, height, title. Width, height, title. That's what it's after. Cool. Get rid of all of that IntelliSense getting in the way a little bit there. Okay. We need a player. We need a coin. And a coin list, and we also need a laser list or a bullet list. Let's call it a bullet list for now. It's a little bit more standard across games. Even if you're firing lasers, call it a bullet list. Okay, so let's go. Self.player is going to be nothing for the moment. Why nothing? So that we can reset the game whenever we want. Self.coin list is going to be arcade dot. No, it's going to be none for the same reason. Getting ahead of myself. And self dot bullet list is also going to be none. Okay. Okay, we need a score. We're going to set that to nothing to start with. And we're also going to say set self.set mouse visible. Self.set mouse visible is going to be false. Don't want to see where the mouse is. Looks a little bit tacky, not so great. So we're going to hide it. Make sure that our users can't see it. Okay, let's get everything actually running to start with. So let's go. Game's gonna make a new variable called game. Set it to an instance of game, and we're going to say arcade.run. Are we running? Should have a blank screen, nothing on it. So good, so far so good. Right, let's get some. But the mouse is hidden. Nice touch, nice touch. Okay, let's get some. Let's write our setup function. This is all a bit laborious. Normally you can pull the stuff down from projects I've already done before, but we're going from scratch again so that one, if you haven't been here before, you can catch up if this is just where you're coming in, and two, you get used to doing this stuff so that you haven't only done it once by the time you come to do your own project. So let's define setup, and setup is going to do everything that we want to do if we decided to run the game again from the start within the game. We weren't actually creating a new Python thread. We weren't actually creating a new window or anything like that. We were just saying, okay, start the game from scratch again. From whatever happened, you lost, and they said, okay, do you want to reset? Yes, and you'd run the setup function again just to reset it in-house, right? Because you can only run that init function once. If you have a setup function, you can run it as many times as you would like. Okay, so now we want self.player is actually now going to be a sprite. Arcade.sprite, and it's going to, what is its picture going to be? Well, it's character idle.png, but it's living in a folder now. So actually it's going to be dot slash for good measure. This is a string, don't forget that. Dot slash images, and inside the images folder, character idle.png, and our scaling is going to be player scaling. Here we go. IntelliSense helping me out there. Cool. Self.coinList is going to be arcade.spritelist, and self.bulletlist is going to be arcade.spritelist. Okay, so far so good. Self.score needs to be reset. And we could set the background here. Let's do that. The tutorial on the website is a lovely color called Amazon. Let's use it. Why not? Arcade.set. You know how to do this. Set background color, and it's arcade.color. Amazon. Why not? Cool. Let's zoom out a little bit just to see if we can get a little bit more of that code in there so that you can follow along. Okay. So far, so good. Don't forget, you actually do need to run that setup function as well if you actually want that that color to happen for those plays to happen as well. Let's create a draw function now, an on draw function, and that'll actually get some things on the screen, and then we can actually start putting some coins in, dealing with the interaction, dealing with the score, displaying some things as well. Okay, so define on draw. Oh, go away. That's what we should have. Define on draw with self in there. I'll zoom in a bit more for you so we can work on this function here. That can disappear now. But now my head's in the way. Oh, getting all of this to work. Okay, define on draw. What needs to happen when on draw? We need to arcade.startRender. And we need to say player, self.player dot self.player.draw, and we need to say arcade dot draw text arcade.drawText, and we need to draw the score. Self.score, of course. And we need to draw this roughly at... I'm going to draw this in the top left-hand corner, so that's going to be roughly maybe 20 pixels in, and height minus 20 pixels. Let's see if that's all right. Oh, it needs a color. Let's make it white. All good. We should have now a player on the screen. We should have a score of 0 on the screen as well. Did I close it? I did close it. Oh, we have an error. Self.coinList equals arcade.spritelist. Type error. Module object is not callable. Capitalization there, my friend. That is not how you run spritelist. Spritelist in arcade looks like this. Fix that up. Very unusual casing for that function. Just one of those things you have to remember. We ran into this problem last time we did this as well. It's an error. And I'll pull my error up a little bit so you can see it. Always good to actually read the error messages. There. Integer object has no attribute split. What is happening here? That is the draw text. It's in this line here. Draw text is trying to split that apart, and that is and it can't do that. So we need to stringify this. So let's actually just make it this. This is a very jank way of doing this, but I'll show you for a moment. This is an F string. So that is now stringified, and it's a string with only self.score inside it. But why don't we say this? And that'll give it a little bit more context as well. Yes. There we go. My character is down the bottom just there, and I've got the score up top. Okay, so I think possibly my player is too small, and I also need to set set her Y position, because I want my player to stay along this line in the bottom. I want her X position to be able to change, but I don't want her Y position to change. So let's set, in the setup, let's set self.player.center Y to be something like 100 pixels up, and let's set self.player.center X to be something like, let's put her in the middle. We're going to change this soon. We're going to get the player to follow the mouse, but until the mouse is actually on the screen, let's just put the character in the middle so you can see it. So where is the middle? How do I calculate the middle? It's width over 2. There we go. I think she's too small. Let's make her bigger. And I think the score is too small as well, but let's leave that as for the moment. Player scaling, let's make 0.8. Ah, that's better. Very nice, very nice. Okay, working well so far. Let's get some coins on the screen. Okay. Coins. Let's get some coins happening. So we need to put, I don't know, 50 coins on the screen. So in order to do this, we need to get a for loop, make a sprite, add that sprite to our coin list loop 50 times. Nice and easy. So for I in range 50, range is a function. Need some of those, need some of those. Coin is going to be an arcade.sprite, and its picture, its actual image is going to be /images slash, I think it's coin.png. Let me check. Coin.png, absolutely. And it's going to be scaled by coin scaling. And self.coinlist dot append coin. And great, we now have 50 coins on our coin list. Are they going to show up on the screen yet? Oh no, of course not. We need to draw them. So we're drawing the player. Self.coinlist.draw as well. Oh my goodness, these inbuilt classes do so much heavy lifting for you. Normally you would have to go through each item on that list, iterate over that list again, draw each one individually, but Arcade just sorts all of that out for you. How wonderful. We have forgotten a crucial step. And we currently have 50 coins just sitting down here. Let's fix that up. Okay, we've made the coins. We actually haven't put them anywhere yet, right? So let's say coin.center x is going to equal random dot randint, a random integer between 0 and width. So anything between 0 and 800 at the moment, and if we change the width later on, that number's going to change with it. How great. And coin dot center y is going to equal random dot randint. Now I don't want between 0 and height. I don't want between 0 and height because my player is only going to be able to fire up. My player is currently sitting at 100. Let's say that they're however many pixels high, 100 pixels high. So for safety, let's make them start at 200, 250. Let's start at 250 height. So anywhere between 250 and height. Now let's give it a shot. There we go. Is that enough coins? Quite little. Should we add some more coins in? Let's add a few more in. Let's make it 80 coins. Just add a few more. Okay. Now we've got the drawing happening. Let's get some movement, and then we'll start to deal with the actual clicking and those interactions, and actually getting the bullets happening, and then getting the touching and the collisions and all of that as well. Okay. How do we get movement? We need an update function. Oops, and it's given me all of that junk again. Define update, and we have this delta time. By the way, this what is this doing? This is what we call a type annotation. Don't worry about it, forget about it, but just needs to know that delta time is going to be a float. Do we use delta time? Not often, but it has to be there in that function. It does have to be there. You can shorten it down to DT. I'm going to leave it as delta time, but I am going to get rid of the type annotation. It's just confusing. It's too much. Okay. Right. Actually, I'm on the wrong track right now. We will need this, just not yet. When the mouse moves, we want to do something. And so actually the function that we want is on mouse motion. And we've got the same thing going on here with all of that junk. If you don't get that autocomplete IntelliSense thing going on, check that you've got... I'm using Pylance. You might be using the other Microsoft version of Python IntelliSense. If you don't get that autocomplete going on, just type it out as is. You do need each of those, x, y, dt, and dy. So x, of course, is the mouse's x position. Y, of course, is the mouse's y position. dx is the amount at which x changed since the last frame. The mouse's x position changed since the last frame. dy is the amount the mouse's y position has changed since the last frame. Because imagine you got one frame and the mouse is here, and then you got another frame and the mouse is here, and it calculates the distance, both in the x and the y, that the mouse has moved each frame, gives it to you in those two variables. On mouse motion, what do we want to have happen? We want self.player dot center x to equal x. Cool. Oh yeah, and just like that, we have motion. We didn't even need to do anything on the on update, but there you go. Cool. Bullets. Let's get some bullets happening. Bullets are going to happen on mouse click. So whenever I click the mouse, we're going to fire a bullet. So define on mouse, and you'll have all of these happen. On mouse press. We're going to get all of that nice stuff turn up again. Bye-bye. And bye-bye to the type annotations as well. They can disappear. Okay. On mouse press, what do we want to have happen? We want a new bullet to spawn at the mouse location. Right. And so bullet is going to equal a arcade.sprite. And it's going to be, its image is, lives in that images folder. And it's called laser.png. And it's going to scale by laser scaling. Go. Bullet dot center x is going to equal the mouse's x position when it was clicked. Bullet dot center y is going to equal, and you finish that line, see if you're right. What do we want its y position to be? Not the mouse y position. We want it to be the player's y position. We want the laser to spawn where the player is, not where the mouse is. So we want its center y to be self dot player dot center y. Excellent. Now we want the bullet to be moving up, and so we can say bullet dot change y needs to be, whoa, what is happening? Needs to be bullet speed. Oops, we called it laser speed. Let's call it bullet speed. Okay, cool. So now we've got the bullet, which is spawning where the player is, and it has all of these properties as well. We need to add it to the bullet list. We need to make sure we're drawing it. We need to make sure we're updating it each frame as well. Bullet self dot bullet list dot append bullet. Cool. Now on our on draw, self dot bullet list dot draw, and on our update, rather than passing, let's make sure we update those bullets each frame. Self dot bullet list dot update. Let's see. Oh, unable to load file. Oh, what have I done? Did I call it laser with an S? Let's rename that. Maybe I spelt it right one time. Maybe laser is spelled with an S. Maybe, I don't know. I'm not going to look it up right now. You can. I'm spelling laser with a Z today, and I'll be wrong confidently. Hey, there we go, and it's working. Why can't you see that? Here we go. Notice something funny? Yeah, I do too. Lasers are pointing the wrong way, and they're a little bit slow. I reckon we should make them a bit faster. Lasers are quick. Let's double that. Let's turn it to 10. Let's turn bullet speed to 10, and let's also, when we spawn the bullet, what we need to do is we need to rotate it 90 degrees. And how did we do this last time when we were making the player face that coin when we were doing the arctan little lesson? What we did is we said bullet, no, well, not bullet, but of course we said dot angle, and we put an angle in degrees by which to turn there, and that should fix up that problem. I did want to make sure that was in there so that we revisited that. Here we go. Cool. Where's my mouse? My mouse has disappeared proper. Gone off the screen. Okay, there it is. No, it's not. Maybe an Alt Tab will get me out of that. That was very interesting. My mouse disappeared completely. I couldn't see it. Okay, great. Well, we now have lasers working, but they're not interacting with anything. How do we get them interacting? We've done this before. See if you can have a go and get these to work so that when a bullet hits a coin, that coin is killed, removed from the coin list, and then something's added to the score. We've done something very similar to this several times already. See if you can do that now. Pause the video and have a go, and I'll see you back here to check the solution. And you're back. Great. Let's go. So we need to say arcade dot check for collisions with list, but we actually have a bullet list that we're checking for. We're checking over our coin list. So this function here only checks a single sprite against every other sprite in a list, but we want to check every bullet against every coin. How do we do that? With our good friend, the for loop. So, for I in for bullet in self dot bullet list. So touching is going to be, so what do we need to give this function here? We need to give, we need to give this function here, we need to give it a sprite that we're interested in, which is bullet at the moment. And the second argument that we need is the sprite list we want check it against, which is self.coinList. Wonderful. Let's pull that a little bit wider, and let's get rid of that there. Okay. And let's say for coin in touching, coin dot kill and score plus equals 1. Excellent. Self.score. Self.score. The self.song. Okay, self.score plus equals 1. Wonderful. Is this going to work so far? I think it is. It's not going to kill bullets when they go off the edge of the screen. It's not going to stop your player from leaving the edge of the screen either. But I might leave those challenges up to you. Oh, we need to close that last version. And here we go. Oh, we have bullets that travel all the way through coins. So of course, we want to stop that bullet as well. So let's add one little line which will do that. For coin in touching, coin.kill. Let's assume that it's only going to touch once. I can see a bug if it's touching more than one coin. Let's assume that's not going to happen and hope for the best. Let's just say bullet dot kill as well, and that should work. And if that bug does turn up, we'll worry about it then. That's a terrible way to program. Don't program like that. Excellent. I can't imagine if I can't imagine that a bullet. Oh, there we go. It happened. The bullet touched two coins simultaneously, and the program didn't crash. Everything carried on. Did we actually add 2 to the score? I don't know. Cool. Excellent. Hey, there we go. That's a really basic version of that game. There are some other things that you could do with this. You could, instead of shifting the character to exactly where the mouse is, you could lerp the character over there. Makes it feel a bit nicer. You could get the coins to move around a little bit. You could make the score a bit bigger and easier to read. You could change the sizes a bit, or maybe you could get power-ups. Change your laser to the version where it hit multiple coins. You could have it time trial where you had to shoot as many as you possibly could. You could have the coins falling down from the sky so that when they went past the player it was too late, you couldn't get them anymore. All sorts of things where you could improve this basic version of the game. But the important part is we now have the ability to fire a projectile and have it interact with something else. You could have made that something else an enemy or terrain even. Something to be really, really careful of is that bullet that you just saw go off the top of the screen. Python is still checking every frame. Is that bullet touching all of those coins? It's very resource intensive. Make sure you clean up after yourselves, which is something that we haven't done here. Should we do it? Let's do it really quickly. For bullet in self.bullet list. Okay, let's just check if bullet dot center Y is greater than height bullet dot kill. In fact, let's just make that height plus 50 to really make sure it's gone off the top of the screen before we kill it. And let's just print. It worked. Bullet removed. And that's going to go to the console just to make sure that this bit of code is actually working. Cool. That's going to save you a lot of bandwidth. Not bandwidth, but processing power, you know what I mean. There we go. Actually, it's actually working. The bullets are being removed once they've gone off the top. We don't care about them anymore anyway. If we can't see it, we really don't care as a player. We sort of expect it to be gone. So just cleaning it up so that we're not using more processing computing than we need to is a very sensible thing to do. And that's it. We'll call it there. We could carry on forever and add more components, but we won't. We'll leave it there. We have projectiles. Nice. See you on the next one.